I'm completely lost. So, A.C. Nielsen reported that children between the ages of 2 and 5 watch an average of 25 hours of television per week. Assume the variables are normally distributed and the standard deviation is 3 hours. If 29 children between the ages of 2 and 5 are randomly selected, find the probability that the mean number of hours they watch television will be greater than 26.3 hours. All right, so now I've got to identify each piece. 25, what do you suppose 25 is? The mean. That's my mu mean, the Greek letter mean. My 3 is what? Standard deviation. 29 is what? It's my sample size. It's how many samples, or how many are in that sample. And then this is what I really want us to pay attention to. The probability that the mean number of hours, they just gave me a second mean, based on those 29 children, is greater than the 26.3. That there is telling me this is my sample mean of 26.3. So when I get two means, it means I've got to do my adjusting, or that process of adjusting. So my picture looks the same though, because I still am talking about, okay, I've got my mean of 25. I want to be greater than 26.3. That looks exactly the same. But I need to do some adjusting now. I can still say, all right, I've got my normal CDF, because that's what I want to try to use. And I want to be above 26.3. So 26.3 is my lowest, and then theoretically there's an infinite amount of time they could watch television, but hopefully not. So you're going to go to positive infinity. Your mean is 25, but now I need to actually apply that adjustment of the standard deviation. So we'll take our given standard deviation of 3 and divide it by the square root of n, which Rn is 29. So I have to make that adjustment, and you can make it before and plug in the adjustment. You can make the adjustment as you go, and the calculator will figure that part out. So let's see. If I go to my normal CDF, 26.3 up to infinity. A mean of 25, and my standard deviation of 3 divided by the square root of 29. And your 29, or the square root is hiding under the squared button, so you'll just have to hit second to get your square root, because it's not one of the top buttons. Did everybody find it? So all I need to adjust is that standard deviation portion. And then I will calculate. And it's going to tell me that my probability for that is 0.0098. Yeah. No, you have to put infinity because you're going to go above, right? 0 would be below the 26.3, so we have to actually put in infinity. All right, so that means the probability, the mean number of hours, actually the probability of the mean hours that children watch television is greater than 26. So the probability that that mean number of hours that the children watch television is greater than 26.3 is 0.98%. If you wanted to round it to 1%, that'd be fine. Yes. Questions on that? So I'm looking at my picture being centered at 96. And we want to know about being between 90 to 100. That should be symmetric, but I'm terrible at drawing that. So we've got normal CDF. My lower is 90, my upper is 100, a mean of 96, and what am I putting in for the standard deviation? 16 divided by 6 or square root of 36. Whichever one you want to think about it as, because 6 is the square root of 36. And let's see what that gives us. So if I go to 1var and get my my distribution support, and I put in 90 to 100, a mean of 96, and then 16 divided by the square root of 36. That tells me that my probability is between, or for being between those is 0.920, well, if we round to 4, then we're at 9210, if we round to the 4 decimals. So what would you tell me?
The probability of the mean of
Probably the mean age of cars is between 90 and 100 months is 92.1%. Questions on that? It actually is works for any of those sample sizes. You can put it in there if you want, and it doesn't matter. You can say the probability that the mean age for the 29 cars is between this is 92%. I'll take it with the in or without. Yes, it changes the standard deviation. Yes. Yes, I'm just saying the x for the lower, and then the x sub u for an upper. Other questions? No. All right. Oh, I left myself a lot of room for some reason. I don't know why. So let's take a look. The average number of pounds of meat that a person consumes per year is 218.4. Assume the standard deviation is 24 pounds and the distribution is approximately normal. All right, what can I identify from just that? The mean, 218.4, and standard deviation of 25. Okay. I want to find the probability that a person selected at random consumes less than 24 pounds per year. All right, so we got 224, sorry. So I'm looking at a mean of 218.4 and then 224 and less. How do I calculate this? If you want to do it by hand. No, I want to find the probability. It didn't give me one. So I'm still using normal CDF. So negative E99 to 224. Mean of 218.4. And what's my standard deviation? 25. Why am I not adjusting it? Because it's one person. And nowhere did it tell me that the mean they consume is less than that amount. So I only have one mean, which means this is an X value rather than an X bar for a mean, a second mean. So this one's just one person. So what does that give me? 886. All right. So the probability a person consumes less than 224 pounds of meat per year is 58.86%. Questions on that? All right, let's check out B. So if a sample of 40 individuals is selected, find the probability that the mean of the sample will be less than 224. That's almost the exact same thing. And actually my picture is going to look exactly the same. So I've got my original mean of 218.4. I want to be less than 224. But this time, the difference is I have an N of 40. And they said that mean of the sample. So I have two means. So X bar equals 224. That's the only thing that tells me this is my different process from the process above. Which is why identification is key as to what you have. Because everything looks super similar for this and the normal, except for that one last step. Where I'm going to say, okay, my given standard deviation of 25, and I need to divide it by the square root of 40 now. Otherwise, I'm going to get a completely different answer. So what does this version give us? Let's see. Oops. So if I go to normal CDF and I've got negative infinity up to 224. And we have 218.4, 25 divided by the square root of 40. 0.92